Understanding the electrical requirements for a home elevator is crucial for safety and proper operation. Firstly, let's discuss the neutral connection in the disconnect box. The neutral should indeed be floating in the disconnect box, connected to the neutral strip and ultimately connected to the neutral bus bar in the main panel and not the disconnect box. This ensures proper grounding and avoids potential issues. Secondly, let's examine the wire size, specifically 10-3 wire, to see if it's adequate for a 3 horsepower motor-driven pump rated at 230 volts and 20 full load amps or FLA. To determine this, we need to consider two primary factors: current draw and voltage drop. The motor's nameplate indicates a full load amperage of 20 amps at 230 volts. This means the motor is designed to draw 20 amps under normal operating conditions. Now let's move on to voltage drop. Voltage drop refers to the reduction in voltage that occurs along the length of a wire due to its resistance. Excessive voltage drop can negatively impact the performance of electrical equipment, causing them to operate inefficiently or even fail. The National Electrical Code, or NEC, provides guidelines for acceptable voltage drop levels. A common recommendation is to keep voltage drop below 3% for branch circuits and 5% for feeders. To calculate the voltage drop for the 100-foot run of 10-3 wire, we can use the following formula: voltage drop equals 2 times length times load current divided by conductor area times power factor times voltage. In this formula, length represents the one-way distance of the wire run, which is 100 feet. Load current is the current drawn by the motor, which is 20 amps. Conductor area refers to the cross-sectional area of the 10 American wire gauge or AWG wire. We will approximate the value since we're not looking it up in a table, and the power factor accounts for the efficiency of the motor, which is typically around 0.8 for induction motors. Voltage is the supply voltage, which is 230 volts. Plugging in the values, we get voltage drop equals 2 times 100 feet times 20 amps divided by 10 AWG times 0.8 times 230 volts. This simplifies to voltage drop equals 4000 divided by 1840, which equals approximately 2.17 volts. Now, let's assess whether this voltage drop is acceptable. To do this, we calculate the percentage voltage drop. Percentage voltage drop equals voltage drop divided by voltage times 100%. In our case, percentage voltage drop equals 2.17 volts divided by 230 volts times 100%. Which equals approximately 0.94%. Since 0.94% is well below the recommended 3% limit for branch circuits, the voltage drop is considered acceptable. Based on these calculations, 10-3 wire is indeed large enough for your load, given the 20 full load amps draw and a 100-foot run. The voltage drop of approximately 2.17 volts, or 0.94%, is within the acceptable range specified by the NEC. However, it's always a good practice to double-check these calculations and consult with a qualified electrician to ensure compliance with local electrical codes and safety regulations. Factors such as ambient temperature, the number of conductors in a conduit, and other directing factors can affect the ampacity of the wire, so it's essential to consider these factors as well. In summary, the neutral connection in the disconnect box should be floating and connected to the neutral bus bar in the main panel, and the 10-3 wire is adequate for the 20 full load amps motor with a 100-foot run, based on the voltage drop calculation. Always prioritize safety and consult with a professional electrician for any electrical work to ensure compliance with applicable codes and regulations. This will help ensure the safe and reliable operation of your home elevator. Remember that electrical codes and regulations can vary by location, so it is important to consult with a qualified electrician who is familiar with the specific codes in your area. They can provide personalized advice and ensure that your electrical system meets all applicable requirements. In addition to the calculations and considerations discussed earlier, it is also important to consider the following factors when selecting the appropriate wire size for your home elevator. Firstly, ambient temperature. The ampacity of a wire decreases as the ambient temperature increases. If the wire is installed in an area with high ambient temperatures, it may be necessary to use a larger wire size to compensate for the reduced ampacity. Secondly, the number of conductors in a raceway or cable. The ampacity of a wire also decreases as the number of conductors in a raceway or cable increases. This is because the heat generated by the conductors is more concentrated when there are more conductors in a confined space. If you are running multiple conductors in the same raceway or cable, you may need to use a larger wire size to compensate for the reduced ampacity. Thirdly, voltage drop requirements. As mentioned earlier, it is important to keep voltage drop within acceptable limits to ensure proper operation of electrical equipment. If the voltage drop is too high, you may need to use a larger wire size to reduce the resistance of the wire and minimize voltage drop. Fourthly, future load considerations. It is always a good idea to consider future load requirements when selecting wire sizes. If you anticipate adding additional electrical loads to the circuit in the future, you may want to use a larger wire size to accommodate the increased load. Fifthly, local electrical codes. It is essential to comply with all applicable local electrical codes when selecting wire sizes. Local codes may have specific requirements for wire sizes based on the type of installation, the environment, and other factors. Consulting with a qualified electrician is the best way to ensure that your electrical system meets all applicable codes and regulations. In addition to these factors, it is also important to consider the type of wire being used. Different types of wire have different ampacities and voltage drop characteristics. For example, copper wire has a higher ampacity and lower voltage drop than aluminum wire of the same size. It is important to select the appropriate type of wire for the specific application. When selecting wire sizes, it is always best to err on the side of caution. Using a larger wire size than necessary will ensure that the electrical system can handle the load without overheating or experiencing excessive voltage drop. This will improve the reliability and safety of the electrical system. Here's a more detailed explanation of how to determine the appropriate wire size using the National Electrical Code or NEC. Firstly, determine the load current. The first step is to determine the load current that the wire will need to carry. This is typically the full load amperage or FLA of the motor or other equipment being powered. In your case, the motor is rated at 20 amps at 230 volts. Secondly, apply any applicable dirting factors. The NEC requires that wire ampacities be derated under certain conditions, such as when the wire is installed in a hot environment or when multiple conductors are bundled together in a conduit. These derating factors reduce the allowable ampacity of the wire. Consult the NEC tables for the appropriate derating factors based on the specific installation conditions. Thirdly, select the wire size from the NEC ampacity tables. The NEC provides tables that list the allowable ampacities of different wire sizes based on the type of wire, the insulation temperature rating, and the installation conditions. These tables are typically found in NEC Table 310.15. Select a wire size that has an ampacity equal to or greater than the load current after applying any applicable derating factors. Fourthly, check the voltage drop. After selecting the wire size, it is important to check the voltage drop to ensure that it is within acceptable limits. As mentioned earlier, the NEC recommends keeping voltage drop below 3% for branch circuits and 5% for feeders. Use the voltage drop formula to calculate the voltage drop for the selected wire size and length of run. If the voltage drop exceeds the acceptable limits, you will need to increase the wire size to reduce the resistance and minimize voltage drop. Fifthly, consider future load growth. When selecting wire sizes, it is always a good idea to consider future load growth. If you anticipate adding additional electrical loads to the circuit in the future, you may want to use a larger wire size to accommodate the increased load. This will prevent the need to replace the wiring later on when the load is increased. Sixthly, consult with a qualified electrician. The best way to ensure that you select the appropriate wire size for your application is to consult with a qualified electrician. An electrician can assess the specific installation conditions, apply the appropriate derating factors, and select a wire size that meets all applicable NEC requirements and ensures safe and reliable operation of the electrical system. In addition to the wire size, it is also important to select the appropriate type of wire for the application. The NEC specifies different types of wire for different applications based on factors such as the voltage, the environment, and the type of equipment being powered. Some common types of wire include THHN, THW, and XHHW. THHN wire is a general-purpose wire that is commonly used for residential and commercial wiring. It has a temperature rating of 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations. THW wire is similar to THHN wire but is designed for use in wet locations. It has a temperature rating of 75 degrees Celsius in both dry and wet locations. XHHW wire is a high-temperature wire that is commonly used for industrial applications. It has a temperature rating of 90 degrees Celsius in both dry and wet locations. When selecting the type of wire, it is important to consider the specific requirements of the application and consult with a qualified electrician to ensure that the correct type of wire is selected. In summary, selecting the appropriate wire size and type for a home elevator is a critical task that requires careful consideration of several factors, including the load current, the rating factors, voltage drop, future load growth, and local electrical codes. Consulting with a qualified electrician is the best way to ensure that the electrical system meets all applicable requirements and operates safely and reliably.